Let's go for other example. So if I have another example, imagine we have the following recurrence relation. an equal to 4an minus 1 plus 7an minus 2 plus 8an minus 3 plus n. So it has how many terms? It has 1, 2, 3, 4, 5 terms. This term, it has an. This term has an minus 1, an minus 2, an minus 3, but this term does not have any ai. So we will label this term as f of n, as a function of n. So the first thing that we need to know about recurrence relation is its degree. And what is the degree of this recurrence relation? It means how far it goes back to its predecessors. Look at the subscripts. Order them from largest to smallest and put them on one side of the equal sign. So we will move all of these three to the left hand, and we will leave the function on the right hand side of the function. After we arrange this, we will have the following recurrence relation. We will have an minus 4an minus 1 minus 7an minus 2 minus 8an minus 3, it's equal to n. Look at the subscripts. n minus 1, n minus 2, n minus 3 in descending order. So you have to start with the largest one and then you keep going down. Probably in some recurrence relations, some of these terms are missing. Maybe you don't have this, maybe it's multiplied by 0. So you will have an minus 7, an minus 2, and etc. How to find the degree? You can find the degree from the last term. Since this is n minus 3, so it is degree equal to 3. Now we have written the recurrence relation in a standard form. This is a standard form of writing a recurrence relation. You just put the terms, the subscripts in descending order, and if any term does not have ai, just put it on the other side. So this is a standard form. Later we will call it homogeneous recurrence relation. As another example, imagine we have the following recurrence relation. It is 3an minus 1 plus 4an minus 3 plus 2an plus 1 equal to 3 raised to power n. So it is not written in a standard form. And we have only 3 terms that have ai. And this one does not have ai, so this is f of n. How we can write it in a standard form? We are familiar with writing recurrence relations in this way. So how we can write it in this way? So we start from n. To find the degree without arranging the recurrence relation, to find the degree, I will write it in different colors. So the degree, you can find it as follows. You take the largest subscript minus smallest subscript. So what is the largest subscript we have? The largest subscript, if you check, this is n plus 1, this is n minus 3, this is n minus 1. So the largest is n plus 1 and the smallest is n minus 3. So the degree will be equal to largest subscript is n plus 1, smallest subscript is n minus 3. So after you subtract these numbers, you will have n plus 1 minus n plus 3. And the answer is equal to 3, and this is the degree. So it is, I think, 4. Sorry, it is 4. So it is 4. So the degree is equal to 4, and this is the degree equal to 4. Now, how to arrange it so that the first term starts from an. So you order the recurrence relations according to their subscripts. The largest is 2an plus 1. What comes next is n minus 1, so it will be 3an minus 1. What comes next is 4an minus 3. It's equal to 3 to the power n. So this is f of n as a function of n. If I want to write it as a standard form, starts from an. So I want to start the first one with an. So I want to have 2an, not starting from n plus 1. Again, observe that n plus 1, n minus 1, n minus 3 are ordered in descending order. How to get from this subscript into this? Notice if you subtract 1 from this subscript, you get n. So the idea is that you just simply subtract 1 from the subscript. So the next one, if you have an minus 1, this is the next one, an minus 1. Just take 1. So to convert it, it will be 3an minus 2. And for the last one, 4an minus 4. And don't forget, you have to make also the corresponding changes to any occurrence of n and the function f of n. So again, you subtract 1, so you will get n minus 1. So this is our equation, ordered from the largest subscript to the next one, to the next one. And again, this is coming from the original recurrence relation. And the degree is, you can find it from the last term. So this is the degree. If you write it in this way, then we say that if you combine all an in one side, then this equation that we are going to get is called homogeneous. So homogeneous recurrence relation. So where is it? It is here. Change the color. So this equation, okay, is called homogeneous. Homogeneous. And for the function on the other side, which is, we have it here, is the function f of n of the recurrence relation. If you have a recurrence relation that you can write it in a standard form and you know the degree, then there are some systematic steps that we can follow to find the solution directly without iterations. And this is what we are going to talk about in the next slide.